Hey everybody, I'm Mark. Welcome into my studio. Today is a build project and it's a fun one. It's one I've been looking forward to for a while. We're going to build a multi-material unit for my big Voron 2.4 printer. But before we get over to the build desk and start working on putting that thing together, I wanted to give you kind of a little background about the motivation for this project and how we got to here. So it actually starts over here with my Prusa Mark 4S. I bought this printer last year as a kit. And just because I've never built a Prusa printer and I wanted to try that. And it actually came with their multi-material unit kit as well. So both of these were kits. I put them together. I've been using them together in this configuration for several months now. And to be honest, when I got the MMU kit, I didn't think I was going to use the MMU that often, right? Because I don't print multicolored things or, even things that need like a different support material or anything like that. I typically print functional parts here for use in my studio or elsewhere in the house, and I just print them out of a single filament and I'm good to go, right? But what the multi-material unit has taught me about myself, and it's probably something that I already knew, is that I'm lazy. And so having 5 different spools of filament loaded into the printer basically all the time, and then just being able to select which one I want using these little number tags that I put on the lines there. When I'm sitting over at my desk, which is over there, and I'm slicing a file to send to the printer, I just look up and figure out which number I want based on which type of filament's already loaded, and I send the file to the printer and we're good to go, right? And so I almost never have to manually change filaments in this printer, and it's so nice because like I said, I'm pretty lazy, and if there's a way to automate a thing, I will always do that rather than doing the same task over and over again. And so my goal now is to do the same thing over here on my big Voron printer. So I've got the same type of filament set up on the wall here, but what I do right now is when I need to change filament, I do that manually. So I unload the filament using clipper screen down here on my screen, and then I unplug this PTFE tubing from whichever container that I was using, and I move it over to the other container, and then I reload the new filament. And I would like to have a MMU system over here that has all of these hooked up so that I can basically do that in an automated way as well, just from my slicer when I'm sending a file over here. And so that's what we're going to hopefully do today. So I've done a bunch of research because I know that there are a lot of different MMU setups that you can add to a any printer running Clipper like this Voron does. But there's a few things that I wanted to kind of keep in mind as I was looking at the different options. First of all, I want to use my system of hanging these containers up on the wall over there. And so that rules out any type of system that actually contains the spools themselves. So things like the box turtle and stuff like that, that actually hold the spools. I didn't want to do that. I basically just want something that works like the MMU that selects the filament, and then that's it. I also don't need any kind of a buffer system because these containers work like filament buffers as well. You can push extra filament back in there and they contain that pretty well and without any issues. And so basically I just need something that selects the filament and then loads it in the printer and just ejects it back out when it's loading the next one. And so what I've settled on, at least for today, and I hope this works, we'll see as we go through today's video, is the Annex Engineering TradRack. So it basically assembles onto a single extrusion, and I've kind of fitted the parts together here to make sure everything's going to fit on top of the printer, and it is. So it's a single linear rail on top of this extrusion that just basically slides a selector back and forth, and then can pick from multiple lanes. And this one actually we're going to build today is going to have either 4 or 5 lanes. We'll see how it goes. But based on the width of this extrusion, I could fit many, many more lanes than that. I think maybe like somewhere between 12 and 14 lanes if I really wanted to. I don't have room on my wall to hang that many different filaments, and so I'm going to stick with just 4 or 5 for today. But this will let me hopefully have the the 4 or 5 standard filaments that I use with this printer hooked up all the time, and then I'll just be able to load them in as needed. And so this thing, we're going to build this on this extrusion. It'll go right back here on the back of the printer when we're done. And then I'll be able to run all the lines up to the wall there where those containers are, and we should be good to go. So that's the idea. I've assembled all of the parts together into a big pile over on the build desk, so that's also ready to go. Just as a note, most of those parts were just things that came from my spare parts collection. So after building a couple of different Voron printers and stuff, I had some extra parts left over, and having modified both of these printers as well quite a bit. So I think I had to buy one stepper motor, And that was about it. Everything else that was called for in the bill of materials for the TradRack was already somewhere in a spare parts bin, you know, somewhere around the studio or the garage out there where I keep all my spare parts. So that was nice as well. Not a huge expense, hopefully, to build this thing. And as long as it works, I think it'll be well worth it. So I'm going to jump over to the build desk. I'm going to get all those parts ready to go, and we'll get started putting this thing together. See if hopefully by the end of the day today I can have this thing on the back of the printer and we can be you know, pushing some plastic through it. That would be nice. Let's see how it goes. All right, so we're over here at the build desk. I think I've got everything I need here. We've got our extrusion that we're going to be building on, our one linear rail that we need, and then in these bins here I've got all of the hardware, fasteners, all that kind of stuff. I've already gone through the entire assembly guide and counted out hopefully everything that I need, and so it should all just be here right at hand as we need it, which should be handy. And then we've got all of these printed parts. So I printed these obviously in colors to match my Voron printer, so some of the blue and some of the gold, and then a few mounting parts in the gray as well. So those should all be ready to go. We've got a few other things. We've got a belt, we've got a cable chain, we've got our 2 stepper motors here and 1 servo motor. This servo motor, by the way, is not the one called for in the bill of materials. It's the only thing that I didn't have something that matched exactly with what they requested. I think that this one will work okay, but we'll see when we get there. If it turns out that one doesn't work, I'll have to bite the bullet and buy the one that they specified in their bill of materials and, you know, replace the servo motor when we get there. But I think that this one should work okay. So again, I think I've got everything I need here. I've got my soldering iron set off to the side here. We're going to need it for soldering a couple of wires, but mostly just for doing heat set inserts into all of those plastic parts. And just to give you a look as well, this is what I'm going to be looking at on my screen. I'm not going to put it up in the video feed for you guys, but if you're building one of these, they have a assembly guide that is very good, that if you've built any sort of Voron stuff in the past, the style of this will seem very familiar. So it's got some nice introductory material here, and then really good pictures as we go through, you know, showing exactly what we need to do step by step, and showing all the fasteners and where everything goes and all that. So this is what I'm going to be looking at on my screen as we build, and I think that's all the background info. So I'm going to go ahead and get stuff that we need for this first bit, which is just putting the linear rail on our extrusion. I'm going to get that ready to go, and we'll get started. So this part should be fairly simple. This extrusion, the official build of the TradRack, comes with these little leg parts that you're supposed to put underneath here, that then you can use to mount onto your printer. I showed you earlier, I have these other ones that we're going to eventually use to mount it onto the printer. So even though I printed these, I'm not going to use those. I'm setting them off to the side, and we'll just go ahead and put the linear rail on here, which is what they wanted us to do next. And so all that entails is putting some of these T-nuts into place, and then we're just going to line this thing up and screw every other hole on the rail down into the extrusion. And they provided these nice little printable guides so that we can snap these on here and get the rail centered. So I'm just going to line these things up and go ahead and get them screwed down. Being very careful, of course, not to let this carriage slide off the ends of the rail. And just to let you guys know, I did go ahead and grease this rail ahead of time. So that is something that obviously you'd need to do, but for me is already done. For now, I'm just getting these screws started, and I'm not tightening them all the way down yet. I will go back and from the center to the outside in an alternating kind of pattern, go ahead and tighten them down once they're all definitely, once they've grabbed onto these roll-in T-nuts. And also, before I tighten this down, I'm going to center it horizontally on the rail, just because I want the final TradRack to be, you know, centered along the rail so that it's centered on top of my printer, since I know that this rail spans from one side to the other of the printer. Actually, I almost eyeballed it perfect. We'll slide it this way just a little bit. All right, that looks good. And since I'm always concerned about the carriage sliding off, I'm going to put these stoppers back, at least on one side. I think on the other side, yes, on this side we have the this little piece, which goes here. And so we can go ahead and put that in place just all the way up against the rail here, and that should stop the carriage from sliding off on this side. Let's be sure. Yeah, we're good. All right, up next is what they call the selector drive end, which will be the large plastic bits of pieces that sit over here on this side that hold this stepper motor, which will be driving the selector back and forth along this rail. And so we need to grab the parts for that, and then I've got some heat set inserts that need to go into those parts first. All right, so now this part slides on to the end of our rail here. I can go ahead and take this little stopper out as well. And it's got M5x10s that go one on this side and then two over here. So I need to put some of these rolling T-nuts here so that I have a place to attach those down, just like so. And then we'll get these screwed down into place. Now this part sits right on top like here. And it also gets connected from underneath with two more screws down here. Now we put this piece on here, and this thumb screw comes from our BMG gear kit, but it needs a washer as well. So we'll do this, and then this. Now we need our stepper motor for our selector driver, which I'm going to use this one. This is the stepper motor I have that's not quite as good. This other one is a good one, and so I want to use that one for, you know, the actual feeding of the filament into and out of the setup. So yeah, this will be the one we use here. And I'm just thinking about wiring. I think I want the wire coming off the bottom of this one. Just looking ahead in the instructions real quick to make sure that nothing's going to block that. Yeah, doesn't look like it. All right, so yeah, I'm gonna leave the wire coming off the bottom here. I think that'll be the easiest thing for cable management. And we do need to go ahead and put our pulley on the end of here first. And the instructions specify a distance here of 1 millimeter from the kind of the surface of the motor here to the bottom of the pulley. That there's no sort of jig or anything like that for it, which is a little bit unfortunate. But I'll do the best I can, and if I assume that if I have to adjust this later, I think it looks like from the instructions that this is going to be fairly easily accessible, and so I should be able to get to this if I need to. And then they're calling for M3x12s to go in here to secure the motor in place. And I'm not going to fully tighten these just yet because I assume there's going to be some belt tensioning later that has to happen. So we'll just make sure they're holding the motor on, but I'm not going to tighten them down all that much just yet. All right, now we've got down in this area here a little switch assembly that has to happen. This is the cover for that. And this is the switch we're going to use. Pretty sure that this is just the end stop switch, right? So that when the carriage moves all the way down to the end, it'll just tap that. And that's how we sort of home our selector back and forth. So before putting this together and putting this cover on it, I'm going to go ahead and find and solder 2 wires onto the outer legs of this switch. And I'm just going to make sure for now that the wire is plenty long enough so that it can reach down the back of the machine down to the enclosure underneath, because that's where it's going to eventually plug in. And it looks like, just based on the spare wire that I have available to me that's long enough, this wire is going to be gray and purple, which is certainly non-standard, but that'll work just fine. So I'm going to get these soldered onto that switch, and then we can go ahead and screw the switch into place there with the cover over the top of it. All right, so I think this assembly is basically done now. We've got, this stops our carriage obviously from sliding here, and when we've got something on the carriage, it should contact this little switch here to be our end stop switch. And then we've got our motor with the pulley up here that will have a belt running across it to drive this back and forth. So that was fairly simple, and everything looks good. So let's move on to the next section. And that next section is the selector module. It's the thing that slides back and forth on our linear rail. And the first step, again, with this section of the build is a lot of heat set inserts. So I'm just going to go ahead and get all of these put in for all the parts that we're going to need for this section so that we don't have to stop along the way and put more in. So this is going to take a little bit of time for me. I'll probably just fast forward you through most of this, because putting heat set inserts in is kind of repetitive and a bit boring to watch, I'm sure. But I'm always careful when I do this, because I don't want to like over insert them or under insert them. I'm trying to be really careful that I end up nice and flush with the surface, that they're going in straight. And that way I won't have any surprises later on when I go to screw things into them. So I'll see you once all of these are in place. And that's all the heat set inserts in place. So now I believe we can build. Let's grab this unit that we've already put together, because we need our carriage on our linear rail here. And what they want me to do is to put 2 screws in here, but not tighten them down. It looks like we're going to slide a piece onto them. All right, so turning this around this way. We can now, there's these 2 slots right here. We can slide this in just like so. And I may need to loosen this one just a touch. There we go. And then that lines these other 2 holes over here with the other 2 spaces in the carriage there. And I assume that we put 2 more. Yes, we do. So we put 2 more of these in those 2 as well. And then I can just tighten all 4 of them down. And they give us this nice hole that goes all the way down through the part from the top here to be able to tighten these 2 that are in these slots in the back. All right, very nice. Now we're going to build a little filament sensor in here, I believe. So they want a 4mm steel ball, which I should have over here somewhere in my parts bin. There it is. Don't roll away. Okay, I think we're good. And that drops down into a little round opening that's going to be really hard for me to show to the camera, but it's right there. Oh, it rolled away. Let's try again. There we go. And then we have another switch, and earlier, I didn't show you on camera, but while I was wiring the two wires onto the end stop switch over here, I went ahead and wired this one as well. This one got yellow and green wires because, again, trying to use up all of my wires. And this is a switch that has one of these little angled metal pieces on it as well. And we're supposed to insert this way. Trying to figure out which way the wires should come out. It does not look like the part itself has any place for the wires to come out, so I'm going to go with this for now, and we'll see if this works. Bringing them out kind of the back side of the carriage like this. But that slides down in there. That angled metal piece on the top of the switch contacts the little ball bearing, and then we've got two holes in the side over here where I can screw in 2 screws to hold that switch in place. So I'll go ahead and do that, and then we will try to test with a piece of filament to make sure that we're getting that, that we're actually actuating the switch when filament goes through the system. So let me get this secured in place first, though. All right, so let me find some filament. And we'll just put it through here. Yeah, and I can hear that switch triggering. My microphone probably doesn't pick it up, and there's a 3D printer running in the background, so you might just be hearing that instead, but for me, yeah, I can definitely hear that switch. So that is good news. Moving on. Let's see, we need this piece and a bearing to insert into this circular opening right here. That press fit nicely in place. And now we can screw this onto this side here with just 2 M3x8 screws. I gotta say, it's a little bit tricky to manage the long wires that I have now coming off of these two switches. They just keep getting in my way as I move the part around to work on it. But I guess there's nothing really to be done about that other than just to deal with it. All right, next I'm going to set this off to the side because it looks like we're going to be building the motor assembly for a little while. And it starts with this piece here. And a 40mm long rod. See, I have two here. This one must be the 30 and this one is the 40. So this inserts here, and they want 6mm sticking out the underside here. We'll just get it exact by using some calipers to measure. Now we can take our motor. It does not say here in these instructions which direction I want this wire to be exiting in. And so, with that in mind, give me a minute to look forward through the rest of the instructions and figure out how I want to orient this thing based on how it's going to end up facing. All right, yeah, I think I want it this way. So the wire's exiting this way, and this side with the rod is kind of on the opposite top corner. I think that's going to work best. And so with that in mind, they want me to use M3x10s with washers on these 3 holes here to attach down into the motor. But I nearly skipped a step. There's a bearing that needs to press into here. I should definitely do that first. All right, here we go. So that one goes there. Right, and now we can go ahead and screw this motor, or this plate, down onto the motor. It looks like also that this is made to pivot a little bit to align some gears probably later on. And so I'm not going to tighten these down super tight. I'm just going to make sure again that they are holding everything in place for now. All right, so now turning this, I guess, this way for the moment. They want me to go ahead and place this BMG drive gear on here. And in the picture, it's got this gear all the way down, solidly against that. I don't know if that is correct, or if we're going to need to adjust that later on, but that's what we'll do for now. And that sits right in here. And then turning it around this way, we've got this 17-tooth gear that we can put on to the motor. And we want this to mesh with this. And so I'm going to have to move this just a little bit to get it to work right. There we go. And we'll go ahead and tighten down the set screw on this little motor gear first. And then I'll adjust this here so that we've got good meshing here between the 2 gears. And I'll go ahead and tighten these down a bit. All right, that looks good to me. All right, next problem with me not reading ahead in the instructions. There's a shaft that goes in here. It's 20 millimeters long. But it's supposed to be 3 millimeters in diameter, and I have a 5. So that's obviously not going to fit. I'm going to look in my stash again and see if I can find a 3x20 millimeter shaft. And if not, we're going to have to pause here until I can order one, because I'm not sure that I have one of those. But let me go look, and I'll be right back to let you know. All right, crisis averted. I found the part that I needed. So we'll go ahead and push this in here. And then this whole assembly sits over the top of this. I guess I need to make sure that I get it pressed down over this piece here. And it says to note in the instructions that this hole here should line up. So this piece here should be sort of lined up vertically. And now we have these 2 little bearings that can slide onto that small 3 millimeter shaft. And it does say here to apply some grease. So before I slide these on, I'm going to go find the little syringe of grease that I use for greasing linear bearings. Here that is. And we're going to just apply a little bit on the inside of each of these before I slide them down onto here. That looks good. And then we'll clean that excess up there. Very good. And then we can put our idler on top of that. just like so, right? So that's going to be where our filament comes through. This looks to be some kind of tensioner. It's going to slide on here. I'm going to temporarily kind of fit it to make sure that I understand, but it does want to have some shim washers on either side of it. So I've got those here. I just wanted to make sure I understood how it fit on there before I put the shims in place. And then it says there's an optional shim you can put on here as well. I don't know if I need it. I'll go ahead and assemble without it, and then we'll see if it looks like I need it or not. How about that? We've got this piece here, which is the opposite, kind of the top side of this whole thing, and it gets another one of these small bearings right there. And then it should sandwich everything together, right? Just like this. So we'll go ahead and put 3 M3 by 25 screws that go all the way down through this entire little stack of parts down to there. Oh, interesting. Now I've just gotten to a step in the instructions that says I can use these 3 bolts down here to adjust the meshing of the drive gear. However, I've already kind of done that. So I think we're fine, but I will go ahead and loosen these up just a bit and double check it. All right, that looks good. All right, so there's our filament drive setup. And it rotates well. Looks good. So now it says in the instructions that there's a spring and plastic washer from the BMG thumb screw assembly, which I think are these 2 parts here. And then I'm supposed to use those in conjunction with my own M3 by 30 screw and a printed part. And I use those all together to make basically kind of a thumb screw setup here. Just like so. And that screws down into here to be our tensioner screw. I don't know how tight I need it to be yet. I'm gonna leave it for now fairly loose. So I saw it kind of runs up against there's a little curved bit on the inside of this piece here, which is how that mechanism works. It's actually really smart design. Kudos to whoever thought that idea up. Nice work. Anyway, yeah, now that I've seen kind of how it engages and how it works, I'm going to leave it mostly loose for now. And so now we can slide this all onto our rail here. And then I assume we need something on the other side to hold it in place so that I don't have to hold it here with my hand. The something is this. And it needs a bearing right here. And then we can use this to hold the other side of this in place. Right, so that looks good, and it needs 2 M3 by 8s to hold it in place. So I'm thinking maybe when I started this and I could have put those feet on the underside of this extrusion, and I told you guys, you know, because I'm not using those, I wouldn't put them on. Maybe if I had put those feet on, this thing would stand up a little bit nicer while assembling it. So they might have been useful just for that, because like it's a bit unstable. It wants to tip like this as I'm working on it. And I'm sure those feet would have helped, but this is fine. All right, so we have this nice sliding mechanism. I can now hear this engaging the end stop switch when it gets to the end here, which is great news. So that's looking good. And now we have to do some things with the servo motor, right? So we've got this piece, an M3x10 and a washer. I'm just gonna thread this in here lightly by hand for the moment. And then they want me to screw this screw with a bearing on the end of it just straight down into the plastic here. So that one's gonna, like, I want to make sure I get it in there nice and straight, perpendicular to the part. And because I'm threading into plastic, I'm going to be a bit careful as I screw this down here. Still a little bit loose. Let's tighten it down just a little bit more. All right, that's good. And the bearing spins nicely. All right, so this whole thing goes on to my servo motor. Trying to figure out if the orientation matters or not. Seems like not too much, at least not yet. I'm sure at some point we'll have to align this thing. And it also says to use the screw that came with the servo motor to, like, once I press this collar on here, we can screw down through this hole here. I don't know that I have the screw that came with the servo motor, so I'm gonna have to go do a little digging around and find a screw that will work. All right, this screw is gonna work that I found right here. However, to be able to get to it, I have to remove this guy. So here's what we're gonna do. We're gonna put that on that way, tighten this down a little bit, use the screw that came with the servo motor, or probably this one didn't, but it's close enough. And we'll tighten that down in there. Yeah, there we go. And we'll tighten this down as well. And then we can put this little screw with the bearing back over here. All right, so that's looking good to me and looks similar enough to what they show in the instructions. So now the servo goes here, right? So this bearing actually meshes with like the little round opening in this tensioning arm. Interesting. Interesting. So this servo motor, as it actuates, is going to adjust the pressure, it looks like, to engage this drive motor here against the filament. So this goes on this back side of the motor like so. And then I'm supposed to use an M3x16. I've lost track of which screw is which, so let's see. Yeah, okay. In through here. So up next are the filament lane modules. And this is one thing I really like a lot about the TradRack design. This is all that you need to add another lane onto the system, as long as you have enough length across your linear rail. And so I'm going to be adding more lanes in the future, I'm pretty sure. But for now, we're going to build, I think, 4 of them. So all that we have to do is we have this single printed part. We have this ECAS coupling that we can just press into place right in the front here for our filament entry. And then we've got a single M3x8 screw and a 623 bearing that go right here into this opening. Again, screwing into plastic, so I need to be a little bit careful as I screw this down. So that bearing works as our idler And that's literally it, right? So this is each lane that we add to the system is just this. If I grab a piece of filament again, I still have the one we used earlier. This is a nice sharp point on this end. So if we run the filament through here, it just runs over that bearing right there and right into the system from there. So that's really all there is to it. So I'm going to build 3 more of these, and then we'll go ahead and install them onto the linear rail. All right, so now these 4 lane modules need to go onto our extrusion, right? And so they want me to start them all the way up against this edge. And all that has to happen, I believe here, let's go ahead and move the selector out of the way and try to get this wire out of the way as well. There we go. So there's just a single screw that goes right into here. And I think we want, like I said, this butted up all the way against that edge. And then we'll stack the next one up against the first one like so. They have these little notches here to help line them up. So yeah, I'm going to put 4 of my roll-in T-nuts in there and then just secure 4 of these guys next to one another. All right, so there's our 4 lanes. You can see here that the number of lanes that are available to me if I wanted to build more of these modules goes all the way basically over to here. Now this is going to have, it's going to have to stop here. So like right about here is the potentially the last lane that I could have. But that's easily another, I don't know, maybe 8 to 10 based on how wide this is right now. So I could fit a lot of lanes here. Like I said, I think probably 5 or 6 is going to be the sweet spot for me, given the number of rolls of filament that I can put up on the wall over there next to the printer. And so I'm unlikely to have more than maybe 2 or 3 more of these here. Although it'd be nice to have a spare one that's not used with a thing on the wall so that I could have, you know, a free lane to feed in filament just sitting on a spool up on top of the printer or something like that. Anyway, I'll figure all that out as I start to use the system more. But for now, that's all that this has to do. And then they also have these little numbered clips. I printed them in this red filament just because I was testing something else with the red filament, but these can potentially go over here to number your lanes. I don't think I'm going to use those because I have those big numbers that I fit over the PTFE tubing that I'm probably going to use the same ones that I use with my Prusa MMU3. So that'll be there. And I think that all that's left is to put the idler end over here that holds the other side of our belt and then get our belt run so that we can drive this thing back and forth. So I'll go grab the parts that we need for that, and that should be the last step as far as the base assembly for this thing. Okay, so for our pulley idler on the other end of the system over here, we have this piece which we can just slide on the end, and I think that I want to just slide it all the way up kind of close to the end here. That should be fine. The exact position of this along here doesn't really matter. It just affects the length of the belt that we're going to need to run back and forth. And I have plenty of belt, so might as well make this real long. Like I assume technically I could pull it all the way up into like here since I only have the 4 lanes right now. But we'll go ahead and just make it the full width. And that way this thing can feel free to slide all the way along here, even though we're only going to use the 4 lanes for now. And all this thing needs is 3 screws, similar to the one we did long ago at the beginning of the process on the other side. So 3 screws, 1 on the front, 2 on the back into the extrusion. All right, now we have our idler. They want a 5x30 shaft. Let me make sure that this one is 30. It is. That's good, and they left a hole here next to the place where the rod gets inserted for you to just put a screw threaded in directly to the plastic just to hold the rod in place. All right, now I believe we get to run our belt. It says to reference the calculator to find the recommended belt length. Or it says cut the belt to length after running it. So since I don't know the exact belt length I'm going to need, we'll just wing it. That seems like the appropriate thing to do, and the thing I do most of the time anyway. So yeah, let's do that. So see if I can turn this so that the camera can see it. It might be a little tricky. There is, on the back side of this little carriage here, this nice little toothed starting point for our belt. So I can just press this down into there. And then we are going to run the belt, obviously, over this drive gear on the motor. Just like so. And that does look straight, so I think the distance from the motor to the drive gear when we did that a long time ago seems fine. Then the belt runs back this way, and there's a gap in the top of this part here for it to just run through, just like so. Then it runs over our idler and back around. So what I'm going to do is roughly estimate the length I'm going to need plus a little extra, and we'll go ahead and cut it about here, and then we'll trim it down to the actual length we need. Just because it'll be easier to manage with the shorter piece here. All right, so that goes through there, that runs over there. These wires are in my way yet again. And there is a little place for it here to tuck in on the other end as well. I should now be able to loosen this screw that I had tightened in place. And then, yeah, you use this thumb screw over here to pull the motor that way, which tensions the belt. Just making sure it's running nice and straight. Looks pretty good. And I don't want it over tight. That seems pretty good. So I'm going to go ahead and tighten these down now, all 4 of them. So now what we're going to do is on the back side here, again, trying to move wires out of the way. We've got this cover. And I suppose I need to figure out, when I put this cover on, where the wires will exit. And I believe maybe the answer I've just stumbled upon is they will exit toward the top. Is that true? Yeah, probably so, because there's an opening here in this part, and there's not really anywhere else they could potentially go. So yeah, we're gonna do that. And there's also, at the top of this blue part right here, there's some little cutouts that are pretty obviously for cable ties if you want to do wire management later on with that as well. So that piece goes right there. Before I do that though, I need to press this in here, because this is going to be where the filament exits out the back of the selector to go to the printer. So that looks good. And then they say we need a single M3x16 screw to screw this cover into place. I do not want this servo motor wire running underneath in between the belt. That would be dumb. Let's do that. I don't know if it's supposed to run through. There's like a couple little openings in this blue plastic part here that it could potentially run through, but I'm not going to worry about that. So this does not need to be in this wire bundle here, just this wire here that's coming out of the switch for the filament sensor. So we'll get this lined up here and screwed in. That looks good. And maybe we should check our filament path again, just to be sure that if, I mean, I guess technically we could check the whole thing, right? If I line this up with this gate and I put filament in, I'm not sure exactly where lined up means. Haha. So maybe I can't check this. Somewhere here the carriage lines up so that it goes through. But where exactly that is, I'm not sure. There it is. Okay. So now if I push that through there, it does come out back here. Nice. And if I were to pivot this servo motor so that this engages, I suppose I could, I mean, yeah, I don't really want to move this servo motor by hand too much, so I'm not going to do it. But this technically could, you know, pivot this down and engage this motor here so that we could feel it gripping the filament with the drive gears. But we'll save that for testing once we get the motors hooked up to the printer and we can control them like they're supposed to be controlled instead. So we've got a cable chain, which I don't know the length that is needed just yet. So I guess we'll figure that out as we go here. There's a piece, it's this piece here, which is meant to be the anchor down below for the cable chain. And they want me to put that somewhere along the underside of this extrusion, but not to tighten it down just yet because we need to figure out where it should go. That makes sense. So for now, we'll just do this. Tighten it by hand so that we can still slide it side to side. And, oh no, heat set inserts. I almost missed them. They are the last two. So I'm going to take this part off and put these two heat set inserts in place. And then we will continue. Where did I put the two screws? There they are. Hopefully you were yelling at your screen. You can't find the screws. They're right there next to the cable chain. All right. Cool. So now this can be slid side to side to figure out where we need to put this thing. So we're going to do this. And I have just realized that I don't have this end of this cable chain. This end is fine. This will go right up here. I might actually break this little piece off here. But the other end, which attaches there, is not on here. So I'm going to go find it. I'll be back. It might take a while. I've got a big bin of parts out there that this came out of. And the extra end is probably just down in the bottom of the bin of parts somewhere. Yeah, I found it. So we'll go ahead and snap this on here. I'm going to close these, at least the ones on the end, for the moment on both ends, just to make it easier to hold this up against the parts as we figure out how long it needs to be. So that can go there. This little tab does need to come off of here. I'm just going to cut it off on both ends because we don't need it to manage the wires. So you're gone. And you're gone. That seems much better. Right, so this will screw here, this will come around. Let's go ahead and attach this end here for now. All right, so now I can test the range of motion of this thing. So if we have that length, which is probably way longer than we need, this runs to that end, no problem. It's got a bunch of extra space, and we can run it all the way down there, no problem as well. I do want this kind of coming off near the middle of the extrusion, left to right. So I guess I could just eyeball it, but also measure briefly. Yeah, so this is probably about where I want the end of the cable chain to be. So I'm going to go ahead and lock this down. Right, and so now I can see I could probably go 1, 2, 3, 4, 5 links shorter, no problem. And if I run this to the other side, if these weren't catching on that thing. One, two, three, four, 5. Yeah, that's still fine. I like it. Okay, cool. So I'm going to remove 5 links on the end of here. And we'll go with that. All right, that looks good. And so now I can take, let's see, this wire and the servo wire for sure. Oh, and the motor wire, right? And run them all 3 down through that cable chain. I'm realizing now this motor wire is definitely not long enough to reach all the way down the back of the printer, which had been my original plan. So that's fine. I can extend it, but I'll go ahead and run this part of it that I can see right here, because we can always extend it from the other end later on. There's definitely no problem with the length of the servo motor wire. That thing is super long. It actually wasn't. I extended it already because I was doing a little testing with it, hooked up to the control board on the printer just to make sure that I could control it. And so in the process of doing that, I added a much longer wire onto it just so that it was easier to reach to where it needed to go. All right, so there's our cable chain. That's already looking cleaner up here, at least. And that motion is great. Yep, no issue at all either on either end of motion. So that is now extra. And then we're gonna have this cable, which is our end stop switch. And we're gonna have a cable running out of this stepper motor over here. And both of those can bundle together with the rest of these and then go down to the printer. So 5 wires total. And looking at the instructions, I think I'm basically now done. They actually have instructions to build a separate little enclosure that you can put up here if you have a separate control board and you're connecting, you know, via like CAN bus or something like that. But again, I'm not doing that. I'm just running these wires straight down the back of the printer and to the control board down in the printer itself. And so the last thing to do will be to take these 2 brackets there and here and mount them on either side so that this thing can sit up on the top of my printer. So I'll do that. I'll get it mounted on the printer. And then I think there's some work we got to do with installing the software that we're going to need to be able to control this thing along with Clipper. It's called Happy Hair. I'm not sure if I'm going to show that on video here or I'll just go ahead and install it, but you can go to the Happy Hair GitHub and find it there if you're following along and doing this yourself. So I'll probably go ahead and at least get that started installed, and then I'll come back and show you guys how it's working and whether or not we can get this thing actually moving and under the control of our clipper setup. So for me, that's going to be a while. For you, it's going to be just a minute, but I'll be right back and we'll see if we can get this thing hooked up and working. Hey there, I'm back. It's a couple of days later for me, and what happened was when I installed the TradRack up here on top of the printer and went to plug it in down to the big TradRack Octopus board that I've got down in the electronics compartment down below. As I expected, I did have enough ports to run the 2-stepper motors and the in-stop pins and all the other stuff that we needed to plug in down there. However, what I had not realized is that my Octopus board, when it came with the kit, didn't come with stepper motor drivers. So these little guys right here, it was missing one, right? So the board itself can control up to 8 motors, but because they were only using 6 for the kit, for whatever reason, they only gave me 7 of the stepper motor drivers. So I was one short. I've ordered a new one. That's what took a couple of days to arrive to me. It just got here yesterday, and I've got it here in my hand. I'm gonna go ahead and put it in the right spot in the control board down there, and then we'll get this thing powered on and give the TradRack a go and see how it works. All right, so with that stepper motor driver installed and everything powered up, I think we're ready to go. So the nice thing for me was that in the couple of days while I was waiting for the stepper motor driver to arrive, I went ahead and installed Happy Hair, which is the clipper extension that can control not just this TradRack, but other MMU units as well. So I've already got that installed. I will leave a link to Happy Hair's GitHub page down in the description of this video. If you're interested in doing this yourself, it's a fairly simple installation process. Just follow the instructions they have there on their GitHub and on the wiki that's there. So once you get that installed, I'll give you a quick look at what I did with my configuration. So it installs this MMU directory underneath your Clipper config, and it's got all of the Happy Hair stuff in it. But before I go in there, I'm going to show you just real quick in my printer config, because I have all of the TradRack things, the stepper motors and sensors and everything else plugged directly into my big TradRack Octopus. I went in here in the top of my printer config. I have these aliases that I created for all of the different pins so that it's easy to remember. And so I added this little section right here, grabbing all of the correct pin numbers for the 2 stepper motors and the servo 3-pin connector where the servo is plugged in, and then the filament sensor switch and the end stop switch. And I've set those all to the correct pins that match the the pinout on the Octopus board itself. That way everything is named nicely. And then all I had to do was go under the MMU directory that Happy Hair installed, and under base here, there is a hardware config file. And again, this is really well commented. So you just scroll down through here and you have to set the different pins. So, here's the UART pin for my stepper motor driver, and then there's a few more right here. So all through here, I just scrolled down and replaced all of the default pins designations with my aliases that I had created. And that was really all that was required to get this thing going. So with those things set, I can now go back here to the dashboard, and I'll give you guys a view of the MMU unit itself there sitting on top of my printer. And I should be able to do things like, if I say MMU home, we should see it move a little there. So it's just finding the end stop so that it knows where the kind of the 0 gate is. And it's already got the 0 gate selected. But if I go MMU select gate equals, let's say 3, it should move over to the 3rd one over. So we can see that. And I'll just actually grab a spare piece of filament here, and we can use this to make sure that everything is lined up, right? So if I manually insert filament right there, it's going to be impossible for the camera to see, but I can see that it's correctly lined up and coming out the back right there. So that looks good. And I can do the same thing for the other 3 gates. I've already done that. I will also show you, actually, if I manually insert here through the gate. Oh, this end of the filament is kind of messed up. Let's go with this end instead. It'll insert much better. Perfect. Okay. Then I can say something like MMU test grip, I believe. And so that should move, it should activate the servo motor that moves the whole unit down to grab onto that filament. So we saw that there. And then we can go like MMU test move, if I can learn to type. and I think we say move equals some distance, right? So now that should actually pull 100 millimeters of filament through. I'll grab this with my hand here. Well, I don't know, it's gonna be hard for you to see it move maybe, but here we go. Yeah, so that looks good. And we can move it back the other way as well. So that looks great. And all of these MMU underscore macros came with Happy Hair, and there's a ton of them. There's some for calibration, there's some for testing different things, and then there's of course the ones that will actually be used in operation of the printer to you know, select gates and load and unload filament and such. So what I'm gonna do real quick is get one of my filament dry boxes set up, plugged into this thing. I've got the whole printer pulled away from the wall, so I can't hang them on the wall in the configuration that they will eventually end up in. But let me rearrange my cameras a bit and get something hooked up here so that we can actually load some filament in and make sure that it's going to be able to load and unload correctly into those dry boxes. All right, so I think we're ready here for a first test of loading and unloading filament through the TradRack. I've got one of my filament dry boxes up here. Normally these hang on the wall behind my printer, but since we're kind of pushed out in the middle of the studio here for testing, we're just gonna set it here on top of the printer. I've got this thing ready to go. It's already got gate 0 selected. And so I'm gonna go ahead and just plug this length of PTFE tubing, which I think is gonna be the correct length once we get this, you know, this thing mounted up on the wall. This will be the length that I use to run to all of the dry boxes. So let me go ahead and grab the filament out of here, go ahead and get it started into this tubing, and then we'll go ahead and do a, I think the macro is called MMU preload. So I'll type that here. Not reload, preload. There we go. And now I should be able to just manually push this in. Yeah, and that works. And then I can go ahead and seal this up. All right, so this is now preloaded to the beginning of the gate there, and it should now be able to pull it the rest of the way down into the extruder. Now I have already gone ahead and preheated the extruder. It's been sitting here at 200 degrees just so that we don't have to wait for it to heat up, because I think the next thing I do, which is MMU load, will require that thing to heat up before it goes and tries to do the load. So we'll go ahead and hit MMU load here, and we should pull this filament down to the extruder and then down into the nozzle. So I can see it coming through the tube. That looks good. And it's almost there right now. So that looks good. The extruder did grab it. I saw the tension on that change. All right, and it says that it's loaded. I'm gonna go ahead and just using my UI here, extrude a little bit. So we'll say maybe 25 millimeters at 5 per second. We'll go ahead and hit extrude here. And that is enough to see some filament coming out. I'm not sure that the camera sees that. But yeah, it is. And I must have had blue in there previously because it's changing from blue to black there. So yeah, it's purged out the blue that was in there before, and there's some black now filament that came out. So if I now say MMU unload over here in my console, it should do its little tip forming process and then unload the filament. Now I don't have any filament cutter installed in this system, so we're relying on the tip forming that comes with Happy Hair. I also have not yet changed any of the default parameters related to tip forming either, so I may need to do a little bit of work with that at some point. It's now pulling back. The extra filament is buffering up here in my container, which this is my first time seeing that. It came off the edge just a little bit there, but I think that'll be okay. The guides will direct it back in when we go to pull it back down. So I think we should be okay there. And I'm gonna go ahead and manually just pull this out so we can look at the tip. Yeah, so this is the tip that I got. Not sure that I can show this close up to the camera, but it's got a very tiny string about that long, where my fingers are here, of extra filament coming off of it. The tip itself looks okay. There's not any sort of bulge or bump, but there is about that much of a very, very narrow string that's coming off of it. So yeah, I will have to go in, and again, the Happy Hair documentation in their wiki is super good about giving you instructions on how to you know, test and calibrate all of this stuff. So I'm gonna have to calibrate the parameters a bit on the tip forming section to try to get this to be a little bit cleaner, because I would like for it to be, you know, basically with this thing broken off like I just did by hand there, just a very short amount of extra string like that. So that's something that I can do after this video is done recording. But other than that, I think as far as loading and unloading and the length of the PTFE tubing and all that stuff and containing everything within my dry boxes, this looks really, really good. So I'm gonna go ahead and probably end this episode of this video now. I'm gonna push this back in the corner and get everything hooked up and back to printing so that I can work on other projects. But there are a couple of things that I still wanna take a look at that I will probably come back in a second episode on the TradRack here and show you guys. One is obviously just doing a multi-material print and showing you kind of how that turns out and testing the reliability of many swaps between filament during a print. Again, that's not something I typically do a lot of. I'm really just going to use this for loading single filaments in there and having, you know, several filaments hooked up to the printer all at the same time. But within a single print, I don't often have the tool doing changes, but it's worth testing for sure just to see how reliable it is. So I'll do that. The other thing is there is a module for Clipper Screen, which runs on my touch screen that's down there that you can't see because I didn't give you a wide enough angle. But there is a fork of Clipper Screen that adds extra functionality to be able to control your MMU from down there on the touch screen, probably for, you know, loading and unloading and swapping filaments and stuff like that. I have not played with that at all yet, so I'll do some playing with that. I'll come back in a future episode and show you guys how that works and if there's anything interesting that I found with that. And then thirdly, there is a extension or a pull request actually that's out there right now on the mainsail UI, so the web UI that you see up there in the top of the screen right now that I've been playing with. There is a whole panel there as well that Happy Hair added that can control an MMU, and that is not officially yet released in mainsail, in the official release of mainsail, but I think it should be soon. The pull request has been out there for a few weeks already, so I think it's just waiting to be approved and merged into the system. So as soon as that's available, I'll also upgrade my mainsail and we can take a look at how that mainsail UI adds functionality to be able to control things related to the MMU as well. So all of those things coming in a future episode here, just to kind of wrap up how this works, and also give you my thoughts on how I've been using it and whether I like it after having printed with it for a bit. So that'll be in the future, but for now, I'm super happy that this was a fairly easy build, and other than just having to wait on that one stepper motor driver part, it was, you know, really easy to get set up and working, and it seems like it's going to be really reliable and good. So like I said, I'm going to get this back in the corner, get to printing, working on projects again with it, and I'll see you guys in the next one, which will probably be another update on my filament storage system. But then in the future, once I've had a few weeks of using this system and got those other Clipper Screen and mainsail things installed and working, I'll give you an update on how that's going as well. So hope you guys have a good one. I'll see you next time. Bye.